Welcome to our teacher app. I am your math teacher. Today we are going to discuss about similar triangles of class 10th. Now we are going to discuss about similar triangles of class 10th. Now similarity means what is similarity? So before going to discuss about similarity of triangles, first we should know the basic concept of similarity. See, similar means suppose if you keep a lamp here, and if you put on the lamp and if you stand in front of the lamp, what happens? My image falls on the opposite wall with a bigger dimension. See, when I move forward, automatically the size of the shadow will be decreasing. Finally, when I reach the wall, what happens? As it is, what shape is now I am having, the same shape will be on the wall. So as I am coming backward towards the light, what happens? My image is going to be bigger one. So if you see the political gathering, at that time they will keep the main politicians statues or cutouts. See the change, there will not be any change or any oddness will not be. See how much the chief minister height will be, according to that they will make into bigger size of the diagram. So both are called similar. See, shape may be different, size may be different, but the two will be in the similar shape, means same to same. So area may be different or size may be different, sides of the particular diagram will be different, but the two will be in similar. That is called similar, means same to same, maybe size will be different. So now when you come for speaking about similarity of triangles, how can we say two triangles are similar? Means when the corresponding sides are equal or when the corresponding angles are equal, then we can say the two triangles are similar. Now in this chapter mainly we will discuss about three theorems. So on the three theorems only, the entire chapter will revolve around these three theorems. The first one is basic proportionality theorem. So this is the first one. So what is called basic proportionality theorem? Basic proportionality theorem is nothing but if in a triangle, so A, B, C, if a line is drawn parallel to one side of the triangle, that means out of three sides, for one side we are taking a parallel line, that is D and E. So I am taking D and E. If this line is parallel to this base BC, then this line will divide the other two sides. Already one side we discussed, this line is parallel to one side, so automatically two sides are going to remain. The two sides will be divided in the same ratio. It means AD by DB is equal to AE by EC. So that is called basic proportionality theorem, and its converse also is there. What is its converse? Converse means just the entire statement from back to front we will speak. That means in a triangle, if a line divides the two sides in the same ratio, then the line will be parallel to third side. What is the basic proportionality theorem? Basic proportionality, this line is parallel to this one, then it divides in this ratio. What is its converse? If this line divides in this ratio, it will be parallel to this one. So these two are the main important theorems at the beginning of this chapter. So depending upon this, we are going to solve so many different types of sums in this chapter. And coming for the next one, what is the next one is in two similar triangles. Similar triangles means if you take a triangle ABC and triangle PQR. If these two triangles are similar, then we will find the corresponding sides ratios squares will be equal. That means the area of the triangle ABC by triangle PQR is equal to, this is AB by corresponding side AB by PQ. So PQ whole square is equal to next BC by QR. So BC by QR whole square is equal to the third one is AC by PR whole square. So this is the another second important theorem in this chapter which we discuss. So the ratio of the areas of the two triangles is equal to, or the ratio of the areas of the two similar triangles equal to corresponding sides ratios square of the corresponding sides ratios will be equal. So this is the another major important theorem in this topic. So on based upon this one also we will do some examples when the areas of the two triangles are given. We are when out of these two, one side corresponding side ratio if it is given, other side we will find with the help of this theorem. And coming for the final theorem, that is third one is Pythagoras theorem. Pythagoras theorem. So what is called Pythagoras theorem? Pythagoras theorem is nothing but in a right angle triangle, so this is 90 degrees, opposite to 90, whatever the side is there, it will be considered as hypotenuse. That is the longest side in the triangle. So its side square, so hypotenuse square is equal to remaining two will be side and side. So side square plus side square, it is the formula invented by Pythagoras. So hypotenuse square equal to side square plus side square. So depending upon this theorem, we will try to solve the last exercise of this topic. So and its a converse theorem also is there. Converse is nothing but from back to front we will write. That means in English how active voice to passive voice and passive voice to active voice. Same thing. See, in a right angle triangle, hypotenuse square equal to side square plus side square is the Pythagoras theorem. Its converse is in a triangle, if sum of the squares of the two sides is equal to square of the third side, then it is a right angle triangle will prove. Just nothing but vice versa. So now, so this is the Pythagoras theorem and its converse is we will prove this is a 90 degrees, that is a right angle triangle. So these are the three important major theorems which we discuss in this chapter. To prove these things, here some axioms also we will discuss. Axioms means nothing but from 7th class onwards you will study, that are ASA, SAS, SSS and AAS. So angle, side, angle, side, angle and RHS. These four main axioms we will discuss in this chapter to prove this similarity of the triangles. So in order to prove similarity of the triangles, compulsory some properties there, either corresponding sides ratios will be equal or corresponding angles will be equal. So in order to prove two triangles are similar, we will use these axioms.